What if the very ground beneath your feet is being sculpted by forces you can't even imagine? New discoveries about Earth's mysterious mantle plumes are revealing their hidden power in tectonic shifts. Prepare to see our planet's surface in a whole new light. Imagine standing on a mountain, feeling solid earth under your boots, unaware that thousands of kilometers below, a churning, molten force is quietly shaping the world you know. That's the wild, hidden reality of Earth's mantle plumes, colossal columns of hot, buoyant rock rising from the depths of our planet's mantle, driving some of the most dramatic geological events we see today. These aren't just abstract concepts scientists scribble about in dusty journals. They're real, dynamic forces, and we're only now starting to grasp how deeply they influence everything from volcanic eruptions to the drift of entire continents. So, what exactly are mantle plumes? Picture a lava lamp, but instead of colorful goo, it's molten rock, hotter than the surface of the sun in places, rising through Earth's mantle, a thick layer of semi-solid rock between the crust and the core. These plumes start near the core mantle boundary, some 2,900 kilometers down, where intense heat causes rock to melt and become less dense. Like bubbles in that lava lamp, this molten material rises, sometimes punching through the crust to create volcanoes, or subtly nudging tectonic plates to reshape the planet's surface over millions of years. They're not just random bursts of heat, they're persistent, long-lived features, some lasting hundreds of millions of years, leaving trails of destruction and creation in their wake. Take Hawaii, for example. Those lush islands, with their black sand beaches and fiery volcanoes, owe their existence to a mantle plume. Deep beneath the Pacific Ocean, a plume has been pumping molten rock to the surface for over 70 million years, creating a chain of islands as the Pacific Plate slides over it. Each volcano marks a moment in time, a snapshot of where the plume's heat kissed the surface. Or look at Iceland, where a plume fuels geysers, hot springs, and eruptions that can ground flights across Europe, like the 2010 Geological eruption that left travelers stranded for weeks. These are the fingerprints of mantle plumes, and they're not just relics of the past. They're active right now, reshaping our world in ways we're only beginning to understand. What's got scientists buzzing today isn't just that mantle plumes exist. We've known that for decades. It's the flood of new data showing how they work and how they're redriving tectonic shifts in ways we never expected. Advanced imaging techniques like seismic tomography are letting us peer into Earth's interior like never before, revealing the intricate dance of these plumes in stunning detail. Think of it like an MRI for the planet, mapping out the flow of molten rock in 3D. And what we're seeing is rewriting the rules of geology. For years, geologists pictured mantle plumes as relatively simple, narrow, vertical pipes of hot rock rising straight up from the core mantle boundary to the surface. The classic model, proposed by W. Jason Morgan in 1971, suggested plumes were fixed points in the mantle, with tectonic plates gliding over them like paper over a candle flame, creating hotspot volcanoes like Hawaii or Yellowstone. It was a tidy idea, and it explained a lot, like why volcanic chains form far from plate boundaries, where most volcanoes occur. But tidy doesn't mean complete. The old model assumed plumes were static, unchanging, and mostly independent of the larger tectonic system. Scientists thought they knew the key players, maybe 20, 50 major plumes worldwide, each powering a hotspot. Yellowstone's geysers? Plume. The Deccan Traps, a massive volcanic region in India linked to dinosaur extinction? Plume. Simple, right? Not anymore. Recent discoveries are showing that mantle plumes are far more complex and interconnected with Earth's tectonic engine than we ever imagined. They're not just lone columns of heat. They're part of a dynamic planet-wide system of convection where hot rock rises, cools, and sinks back down in a cycle that drives plate tectonics itself. And they're not always fixed. Some plumes wobble, tilt, or even split apart, influenced by the chaotic flow of the mantle around them. This is a game changer because it means plumes aren't just passive sculptors of the surface. They're reactive players in the tectonic dance. So, what's sparking this revolution in our understanding? It starts with technology. Seismic tomography, which uses earthquake waves to map Earth's interior, has gotten insanely precise. By analyzing how seismic waves slow down or speed up as they pass through different materials, scientists can now create detailed 3D images of the mantle. It's like shining a flashlight into a dark room, revealing structures we couldn't see before. And what we're seeing is wild. For instance, a 2023 study revealed that the Hawaiian plume isn't a simple pipe, but a sprawling fan-like structure, with tendrils of hot rock branching out over hundreds of kilometers. This suggests plumes can spread out like the roots of a tree, feeding multiple volcanic systems at once. Another bombshell came from the Yellowstone plume, long thought to be a classic hotspot. New imaging shows it's tilted, leaning sideways as it rises, possibly influenced by the sinking of cold, dense slabs of crust from nearby tectonic collisions. This tilt could explain why Yellowstone's volcanic activity has shifted over time, leaving a trail of ancient calderas across Idaho and Wyoming. But it's not just about individual plumes. Scientists are now mapping a global network of mantle flow where plumes interact with each other and with tectonic plates. A 2024 study suggested that plumes under Africa and the Pacific are linked to a massive superplume structure, an enormous upwelling of hot rock that could be driving the breakup of continents. This superplume might explain why East Africa is splitting apart, forming a new ocean basin that could, in millions of years, turn the Horn of Africa into an island. It's not just geology, it's the planet remaking itself. Mantle plumes don't just sit quietly in the deep earth, they leave dramatic scars on the surface. Volcanoes are the obvious ones, but their influence goes way beyond that. Plumes can trigger massive outpourings of lava called flood basalts, which cover vast areas and reshape landscapes. The Siberian traps, formed 252 million years ago, spewed enough lava to cover an area the size of Australia, likely triggering the worst mass extinction in Earth's history. Today, smaller but still intense eruptions linked to plumes are shaping places like Ethiopia's Afar region, where new crust is forming as the continent splits. Plumes also mess with tectonic plates. By injecting heat and material into the base of the crust, they can weaken it, making it easier for plates to crack or slide. This is happening right now in the East African Rift, where a plume is helping to tear the continent apart. Over millions of years, this could create a new ocean, redrawing the map of Africa. Even subtler effects, like the slow uplift of land over a plume, can reshape landscapes. Southern Africa's high plateaus, for example, owe their elevation to a plume that's been pushing up the crust for tens of millions of years. And then there's the climate angle. Plumes don't just shape the land, they can change the air we breathe. Massive volcanic eruptions from plumes release huge amounts of carbon dioxide, sulfur, and other gases, which can warm the planet or, in some cases, cool it by blocking sunlight. The Deccan traps, linked to a plume, played a role in the climate chaos that killed the dinosaurs. Today, scientists are studying whether smaller plume-driven eruptions could influence modern climate patterns, especially in regions like Iceland or the Pacific Ring of Fire. Why should you care about something happening thousands of kilometers beneath your feet? Because mantle plumes are shaping the world you live in right now. They're not just ancient forces, they're active players in today's geological dramas. The East African Rift is growing wider every year, with measurable earthquakes and volcanic activity. Iceland's plume is fueling eruptions that disrupt global travel and economies. And understanding plumes could help us predict where the next big volcanic event might strike. Think Yellowstone, where a super eruption, though unlikely in our lifetime, could reshape North America. Plus, plumes hold clues to Earth's past and future. By studying their trails, like the volcanic chains of Hawaii or the Emperor Seamounts, we can reconstruct how continents have drifted over millions of years. This helps us understand not just where we've been, but where we're going. Will Africa split into two continents? Could a new superplume trigger another mass extinction? These aren't sci-fi questions. They're real possibilities, rooted in the restless churn of Earth's mantle. The discoveries keep coming. New tech, like machine learning applied to seismic data, is helping us map plumes with unprecedented detail. Scientists are also drilling into plume-related rocks like those in Iceland or the Kerguelen Islands to study their chemical signatures. These rocks tell stories of where plumes come from. Some may even tap into primordial material from Earth's formation, untouched for 4.5 billion years. And then there's the big picture. How plumes fit into the grand puzzle of plate tectonics. Are they the main drivers of plate motion, or just one piece of a larger system? A 2025 study suggested that plumes might anchor tectonic plates, slowing their movement in some cases or speeding it up in others. This could explain why some continents, like Australia, have stayed relatively stable, while others, like Africa, are fracturing. Mantle plumes are more than just geological curiosities. They're the heartbeat of our planet, pulsing with heat and power that shape everything from mountains to oceans. The ground beneath your feet isn't as solid as it seems. It's alive, moving, driven by forces we're only now beginning to understand. Every volcano, every earthquake, every new island rising from the sea is a reminder of the unseen world below us, a world that's been shaping Earth for billions of years and will keep doing so long after we're gone. So, next time you stand on a cliff or walk across a plain, think about the molten giants lurking below. They are not just sculpting the Earth, they're retelling us a story of a planet that's alive, restless, and full of surprises. And thanks to new discoveries, we're finally starting to hear that story loud and clear.